Good morning, Vienna. How's everyone doing? Heavy night? Show of hands who went to Hard Rock? Oh, well done, you guys. Turning up in the morning on time like this. Bit of a pat on the back. My name is Yves. I work for AWS. I'm here to talk to you not about Narnia, but about KRO. Unlike Narnia, it is part of Kubernetes. And we have open sourced it last year. So I'm really, really excited to sort of discuss how one could adopt KRO into your platform building context. In my talk, I hope to sort of lift our heads up a little bit, look into what's platform engineering in the context of building your own platform with your platform engineering team. And what Laura said earlier regarding developer experience really resonated with me. Agent experience, I'm going to definitely check out. But my talk isn't going to be Gen AI related. It is going to be developer experience a little bit, again, in the context of platform engineering. So sit back and relax. When I work in, well, I am working at AWS, and I very often work with customers that are building their own platform. And we see a shift from what used to be a very decentralized way to build platform, or platform engineering, or IDP, with the hope for flexibility, empowering the application teams, and so on. And this shift has come recently, I guess last year or the year before, that teams and the direction of their platforms are now being centralized. We're seeing a lot more, for example, platform centralized staff, engineering departments that are sort of handling all the platform engineering needs. But the question still remains for both top leadership, for line of business, but for ourselves, developers, SREs, and platform engineers alike. How should we spend our time, as Laura sort of alluded to? Do we want to build a platform where we can tinker and build out every single component, or do we want to give our developers a platform where they can go from A to B basically immediately? Again, Kubernetes is so flexible. The choice is entirely up to you. My talk is it's about yet another example to do resource orchestration. But again, every time I'm stuck, I very often look towards everyone's favorite chief architect, Martin Fowler, where I find this sort of sage advice where it says, platform engineering basically boils down to a foundation of self-service, knowledge, and support that are arranged in a compelling internal product fashion. And I think what's really important when we deal with sort of Kubernetes resources and platform engineering as a whole is to always consider this as an internal product. Talk to your developers, capture their challenges and pain points, build that into templates or golden path or whatever it is that makes your developer a little bit happier, a little bit more productive. And we see that, and this is no surprises, and I think I'm preaching to the choir here, that Kubernetes in itself is excellent for building platform. Right? It has declarative configuration, super extensible through operator patterns, and we do see Kubernetes being adopted for a lot of the modern platforms that we have today. So what is it about Kubernetes that makes it such a strong offering for platform? And in the context of platform, working ground up, we see that Kubernetes gives us an easy way to configure and manage infrastructure, and we always need quality infrastructure to a point where we could have a really reliable control plane. Where I think things gets interesting is what do you then expose to your developers? How should they interact with your Kubernetes clusters? Should they be, in fact, managing the entire lifecycle, update and patching? Well, as mentioned earlier, we see a shift in this, and we see that this is being centralized. Platform teams are, in fact, building out their own toolings, templates to support the needs of application teams. But that is not without its challenges. We see that Kubernetes has a steep learning curve for developers. Deploying your first pod is relatively straightforward, plenty of hello world examples. But then going to 300, 400 plus levels, going into multi-tenanted AI workloads, for example, can get daunting. And when we speak to customers, they do see that it is challenging both for developers, but also for the platform. How do we then standardize, simplify, and sort of give a unified experience for all the teams while making sure that we are sort of keeping the complexity as low as possible. And we know that developer wants flexibility. We want the freedom of choice. I've been a developer for very, very many years, and the biggest thing I hope for is that I get to deploy my application the way I really want it to. Whereas when I put on my DevOps, long time ago, hat, I want to standardize and ensure that the infrastructure and the platform is running super smooth, super secure, and very likely compliant. Where things meet in the middle, we find, is this operator pattern where you have controllers and custom resource definitions. Just a show of hands, who's written their own controllers here in the room? Yeah, quite a number of you. Yes, and this is a common pattern we see also out there with my customers. So we see that this is kind of a good meeting in the middle type of thing, but can we do things better? When we think about what is an application, how it is being composed, for example, if you take any application, for example, typically you then outline how would you like it to be deployed, right? Maybe you have a control plane. How would you like to scale this? Maybe you use Carpenter. Excellent. Do you need persistence layer? So already this is like a typical vanilla deployment scheme here you're looking at, but it is about composing other resources within the Kubernetes world. Again, so where does the custom resource definition sit in this picture? Is this the responsibility of the application team then to build out a controller, to sort of redefine their stack and maintain that as well as the application? Can we do things better? After speaking with a number of customers, we've come to a conclusion that perhaps actually custom controllers don't implement any differentiating business logic. So we see that, or at least I see that, effectively when you write your own custom controllers and you're maintaining this, it is perhaps a technical debt. Would this be a new feature that could be built in Kubernetes, for example? Can we just rely on one controller that sort of allows you to compose any resources you like, using any plugins, any existing controllers, and build on top of that? What does good look like? When I consider this, I think about the separation of responsibility. Like, what is the developer experience when I interact with my cluster? I see that as a developer or an application team that I pretty much only care what Docker container I'm shipping. Does it have an ingress endpoint? What is it? Can I hit the database all right? Yes, I can. Fantastic. And I want to ship that. I want to ship that both in testing, QA environment, for example, and production. But you know, again, that Kubernetes is far more than just that. So then the way I see it is then you have a platform team and perhaps working closely with security and compliance, for example, that gives you the observability, that gives you sort of the underlying tooling in a standardized manner. Certainly, they don't really work directly against your application code, but they are providing sort of a safe housing and runtime for your workloads. Again, the traditional infrastructure should be part of that platform piece. This, to me, is kind of what good looks like. This, to me, seems like a very scalable concept that you can put it into a blueprint, a golden path, add your batteries, out they go, ship them out, super replicable in the form of instances. But again, where does these custom controller CRD comes in then? Who really should be taking care of this? And I think this is, in my opinion, what KRO does best. It is a lightweight Kubernetes resource orchestrator, allowing you to configure and compose whatever instance of templating that you want to ship. Again, as I mentioned earlier, this is an open source way to do it. This is a project that came out of AWS, and it is gathering a lot of steam. There's a lot of contributors, 45. I have to read the slide a bit, it's so small. And we have maintainers from the community. as Andreas mentioned, I'm passionate about community engagement, and I think this is one of those projects that is bringing a lot of people together, which I think is very nice. I will be showing a demo, so yeah, so don't worry. So platform engineering with KRO, what does it do? What does it do differently? So as opposed to, for example, given a situation that you might have a custom resource definition with its own controller, and as your team scales out, they have their own way of working, their own sort of processes, all encapsulated in their own controller logic. By using KRO, you can start thinking about doing away with all of that. Right? There is a way that you can standardize, but you can still migrate to this KRO-only controller future if you wanted to, by reusing existing resources, which I think is really, really nice. So I mentioned KRO itself using resource graph definition is super composable. Now I'll show you that in a bit. And it can certainly replace the old CRD authoring. Keeps things very, very lightweight. This is what KRO is good at doing, really, nothing else, which I think is very, very nice. I've had this talk earlier in other places, so very often I think when you look at the developer experience through platform engineering lens, that you see that we're now reusing and defining what our stack could be through resource application, resource graph definition. Jesus, it is a bit early. I too had a few glasses of wine last night. And these are extensible, and developers effectively interact with this by creating instances of the resource graph definition. And ultimately, it is a simplified, in my opinion, developer experience where, well, perhaps now you can argue your developer does not need to create their own CRDs, but perhaps understand the schema and the supported resources that are composed in the resource graph definition, allowing your platform engineering team to go ahead and define them. To me, this is a very clear way to work, to also abstract away some of the complexities, but without taking anything away from the application team, should they want to dive a lot deeper. But let's see it in action. I have some time left, which is really nice. Okay. So I guess my only contribution this year in terms of Gen AI and platform engineering is I now adopted Jupyter Notebook for my demos, which I think is amazing. I had a lot of time building out this demo, partly because I think trying something new is really nice, but also I think this summer I just came from Bali, amazing place, so I kind of want to keep that feeling going. So I want everyone to imagine this, that we're a small startup that manages holiday homes in Bali. We have a small application team that would like to manage these beach house bookings, if you will. And the team have, for whatever reason, decided on Kubernetes. Personally, I would say that's a little bit of a red flag. Like, why are you dealing with Kubernetes? If you're a startup, you should be focusing on shipping software and maybe getting your next rounds of funding, and let's not do this. But however, I thought I would just highlight the importance of KRO. But as we know, in all things Kubernetes, it is API all the things. My demo is done in Minikube, which I think is quite nice. And as you know, everything is an API endpoint in Kubernetes. And I think that in itself, a concept is super flexible, super extensible, makes it really, really nice. For those that are using, building out your own controllers, defining your custom resource definitions, this is no surprises, right? Like, this is what Kubernetes is super good at. That, for example, if we were to tackle this as a small team managing Bali beach houses, it's very likely that maybe this is one of the way we will build out our platform, if you will. Like, we'll make it easy to specify what our application can do by building out our custom resource definition. But let's take a look at what that is. Can everyone see okay? It is awfully bright in the stage. But like any other sort of custom resources, you define what your schema could be. In this case, and in our case, this is all about the location, because in Bali, everything is important, whether you're in the jungle, you're next to the beach. How many bedrooms, and does it have an ocean view? Us as a team felt that was a very, very good way to specify this specific resource. But we apply it, we deploy the controller, Bob's your uncle, and then it is running. But this is not quite enough. So for those that are building their own controller, why are you building a controller? Because you want to interact with these objects as they're being created, updated, deleted. You want to be able to do the right thing, whatever that right thing might be. And this, to me, is the heart of the very, very powerful operator pattern. So let's take a look. For those that's maybe never built a controller before, this is kind of like a very simple way to get started. I use Conf. And in a very sort of annotated way, I'm able to hook in to some of the lifecycle events. But for the purpose of the demo, we're just sort of showcasing that we just want to log this. So it's doing nothing too fancy. But as you build your controller, you also need to containerize it. So in itself, it's an additional piece of artifact that you need to manage the lifecycle effectively. Of course, the next thing you do is go ahead and deploy it. So let's do that. So that's very nice. Once your CRDs and controllers are there, you can then interact with it. So let's create a jungle retreat. Let's create this thing in Canggu and so on. All very nice. Everything works right at this point. You have the new resources created. Your team can start defining it, and you can sort of start deploying whatever it wants you to do, which is very nice. Where I think it gets interesting is then how do you scale this, right? So this is where it gets a little bit tricky in the sense that, okay, well, what if our startup is now turning into a ginormous enterprise comprised of 50 development team, each team comprised of 10 developers, because we like our 2 pizza-sized team. It's not so straightforward anymore. So who is going to maintain this controller? I have my own needs. Our teams are integrating with different things. Should we then all use the same Bali resort model? So for the sake of this demo, we're sort of adding this really, really popular service in Bali called Gojek, which is like Uber. It delivers your food. It gets you from A to B. We feel like that would be a good addition to our business. And we want to add that to everything we deploy. And this is where, let's say, we introduce CRO, right? Okay, our thinking is, for example, instead of keep on building on this controller, why don't we build on top of the existing controller and expand that way by building out with CRO once and for all? So that means that you can reuse the old controller if you like, you only deploy this one controller once. How do we use it? Well, we first define first we make sure the CRO is installed, and it is. We then define the resource graph definition in this case. Okay, we have 5 minutes. No, we have a bit more. Okay, very good. And the resource graph definition is an interesting one. This is where the power of CRO sort of comes in. A little bit different from how you define custom resource definition is that, one, you define the spec. Looks very similar. In this case, we've added a webhook. We added a Gojek integration, some kind of booking system, just for the sake of this demo, and so on. Where the composability comes in is under this resource section. So you can see that I'm reusing the beach house resource that we have built when we were just a startup. For whatever reason, our line of business, for example, doesn't want us to throw it out. I can now reuse that. I'm not throwing it away, I'm going to reuse it. I'm also going to compose and add additional Kubernetes resources, in this case, a config map. All of these sort of basically configuration all needs to go somewhere, but you can imagine where this is going. You can add more and more resources. It could be a deploy resource, this could be ingress, this could be, I don't know, something through ACK on AWS, a database, this could be anything across any clouds, and you define it all here. And I think that's a nice way to work, and I think this is both flexible and it's giving you a single way to define things where dependencies are also managed properly. Right, so then we deploy this resource graph definition. So the next thing we want to do then is actually consume it. But again, as a developer, what is my developer experience? I can see that when I describe and explain the spec of this new resource, it comes back with the fields, and I don't really need to think about, is it that Kubernetes resource I need to reuse? Is it that other thing? I see it very much from an application point of view that now I need to integrate with a third-party system. What are the endpoints? Where do I pull the credentials? And let somebody else worry about the connectivity and the security of it all. Although security is our top priority, so you should care about that. So let's go ahead and create some resources. I really like this Jupyter notebook. Everything is so scripted. Now we've done that, let's get the both the new resorts as well as the old beach houses. So here you see that with KRO, we have created 2 new resources, which is very, very nice, but we're still using the old, which is also very good. And it sort of gives you this migration path out of the older controller if you want to, or you can outright replace and upgrade it if you want to as well. Much like anything else, we check the logs in the old controller, but KRO logs is an excellent place to look if, for example, you're finding it difficult to deploy. This is where you can find the reason why. So another good thing with KRO is that if you specify the resources wrong, it's able to pick that up. If you are making breaking changes, this is where you'll also see that before you even try to deploy anything. So I think that's, again, a very nice bonus. And now to sort of wrap up the demo real quick, that now we see that there's two items that are managed by KRO, and we haven't thrown out the old controller, which is really nice. It's definitely making people happy. So again, I think in a very, very simplistic way, this addresses the composability quite nicely in terms of pulling in other resources and standardizing a way to deploy your application. In my opinion, it gives a really, really strong developer experience by abstracting away the complexity. Yes. Okay. Okay, so just quickly to wrap up, I actually don't have that much more to go through, so happy to take some questions. Again, KRO is open source. We like working with community, and I think this is a great way, a very light way to do Kubernetes resource orchestration. Again, it's dynamic, and it detects the breakages very much ahead of time. It follows the open API support as well, as you see in the spec file, and hopefully avoid this YAML controller hell that some of our customers are going into. What's interesting is that it is a structured approach whereby it is entirely in YAML, it's declarative, hopefully easy to reason with, but it is not complex constructs or no support for loops. And we believe that's expressive enough. So it will be interesting to hear what people think about that one. Automatic dependency management, I think that's really nice, using DAG. Does that for you out of the box. And you don't need to explicitly, if you're familiar with Terraform, to say depends on and this and that, and this should happen before that. KRO will just handle it for you, which I think is very, very nice. with that in mind, hopefully made the 30 minutes mark. This is still quite early days, but there's a lot of interest, so reach out. As Andy said earlier, there is this AWS game. I hope everyone is getting on that. I think the training certificate is very compelling. Love to speak to you about Crow or anything else. You can always find me downstairs today. Thank you very much.
Thank you. I'm pretty sure we will see a spike in people booking trips to Bali now. Also, the Jupyter notebook is really nice. Is this also the demo that you had? Is this somewhere on a GitHub repository for people?
Yes, yeah. I haven't done that, but I will. I will make it available. Absolutely, and I'll share it with you, maybe through LinkedIn, and I'll let you know. Andy.
Perfect, yeah. Also, it's good to remind people to follow you on social media, because that's when they get all the demos and everything. So, folks, we have time for questions.
Hi, thank you for your talk. I'm really intrigued, but at the same time having a hard time figuring out where exactly it fits in, especially when it compares to something like Kubevela, which does it for Kubernetes only resources in a way, or Crossplane, especially in the new version 2, where it does the same thing for Kubernetes and cloud resources. Where do you think this would fit the space of the tooling that we currently have already?
Yeah, that's a very, very good question. I was kind of expecting that as well. The way I see it, and this is my personal opinion, I think Crow does one thing and one thing only really, really well, which is to compose your resources and exposing it in a sort of declarative way. And of course, you're not short of choices here. Kubevela, Crossplane, all do that. In my opinion, I think Crossplane is really, really feature-rich. So with Crow, it won't, out of the box, for example, create AWS resources. You need to use something like Crossplane and ACK. So I think there's no really an easy answer here, but to say, again, this is yet another way to potentially compose resources. And what I know the development team in Crow and the community is thinking is that to keep it as lightweight as possible. This is what it's good at, and very likely this will only be what it's going to do. It doesn't want to do too much more than that. And to me, I think it's a very nice way to, if you are starting fresh, plugging in Crow with other sort of cloud-specific controller and orchestrators works really nice, because it doesn't take too much. However, if you're already on a very feature-rich setup and you love using it, yeah, by all means, yeah.
Any other questions? Yeah, Nico is already running. Perfect.
Yeah, thank you very much for your technical session. So I just need to ask that does Crow implements complex reconciler logic? Like if we need to compare Crow with the operator pattern, we must have some way to implement a complex reconciler logic and control that. The thing I understand, like it supposes composition, but to have a exactly replacement of operator pattern, you need to have some complex logic handling in reconciler logic. Yeah.
Yeah, good question. So it's about. I think I'll keep this one short. Love to hear your use case down at the booth and dive a lot deeper. Again, Crow is very lightweight, and today it is still in beta. It does what it does really good, and perhaps it can do a little bit more. Precisely to your point. So come grab me afterwards downstairs. I'd love to hear your thoughts.
Anybody else? Raise your hand. Nico is on his way.
And you get a candy.
Yeah, the candy. It's not even Halloween yet, and we get candies. Knock, knock. Cool. Otherwise, I would say we start with an earlier break. Be reminded, folks, we continue at 10:50. So you have a good, nice break, which allows you to spend more time downstairs with the sponsors. Check out the AWS booth, get on that game, and get your questions and your feedback discussed with the speakers.
Absolutely. Thank you for having me.
Thank you.